Okay, let's dive into something that I find absolutely fascinating. We're going to explore a connection that stretches across thousands of years, linking the very first ideas in mathematics to the artificial intelligence that is completely changing our world today. So what on earth does a 2,000-year-old math puzzle have to do with AI? I mean, it sounds kind of crazy, right? These two things seem worlds apart, but believe it or not, the answer reveals a single, incredibly powerful idea that connects them. It's like this hidden thread that runs all the way from ancient Greece to the phone in your pocket. All right, so to really get this, we've got to go way back. Thousands of years ago, a huge shift in thinking happened. And the real breakthrough wasn't finding the answer to just one problem. Nope. It was about discovering a whole new method for finding answers to pretty much any problem. And this was the total game changer. The idea that you could take a messy, real-world puzzle, one just described with words, and translate it into a clean, simple structure, a mathematical sentence. Suddenly, math wasn't just for counting stuff anymore. It became this powerful language for understanding how the world actually works. Now, a key player in all of this was a guy named Diophantus of Alexandria. He's often called the father of algebra, and for good reason. He was one of the first people to look at a word problem and think, hey, what if we just replace the unknown parts with a symbol? It sounds so simple to us now, but that single act, that idea of substitution, let him build and solve equations in a consistent, powerful new way. It was revolutionary. So what does this big idea actually look like in practice? Let's break it down with a super simple example. Now, to us today, this is going to seem really basic, but you have to imagine what a huge leap forward this was at the time. Okay, here's a classic word problem, right? Find two numbers whose sum is 10. When it's just written out in words like this, it's just an idea. It's a question that you kind of have to hold and juggle around in your head. But the method that Diophantus was pioneering offered a totally new way to tackle this. Instead of just thinking about the words, you could translate the entire puzzle into a compact, symbolic statement. And boom, there it is. X plus y equals 10. You see what just happened? The problem is no longer just a vague idea. It's a concrete structure. It's an equation. It's something we can actually work with, manipulate, and solve. This one little step, from words to symbols, changed everything. Now, this powerful way of thinking didn't just stay in the world of math puzzles. Oh no. It evolved, it grew, and it eventually became the language we use to describe the universe itself. You can see this incredible evolution over the centuries. It starts with algebra in ancient Greece. Fast forward to the 17th century, and we get calculus, which lets us explain motion. Then, in the 19th century, statistics gives us the tools to handle uncertainty. And then, bam, the 20th century arrives, and modern computing just pours rocket fuel on the whole thing. Math became the engine that drove science forward. What scientists started to realize was that nature follows rules. It follows patterns. And the amazing part? Those patterns could be written as equations. I mean, think about Newton figuring out the motion of the planets, or Einstein describing the behavior of light and gravity. Math became the language of reality. It was like they discovered the universe's source code. Okay, let's fast forward all the way to today. We're now facing a completely new kind of universe to explore, one that's just as vast and complex as the cosmos ever was. We are absolutely surrounded by these massive oceans of information. I'm talking about financial markets, social media, scientific research, you name it. And hidden deep inside all of that data are complex patterns just waiting to be understood. And the parallel here is just striking. Physicists wanted to understand the physical universe using the language of natural laws. Well, today, data scientists are trying to understand the universe of data using the language of statistical models. The subject has changed, but that fundamental method, translating a problem into a structure you can solve, it's exactly the same. All right, so let's finally connect this all back to artificial intelligence and see that ancient idea at work in our most advanced technology. And this really gets to the heart of it. Even the most complicated AI system today follows that ancient pattern. It doesn't matter if you call it data science, machine learning, or AI. The foundational idea is the same. You take a messy problem, you give it a mathematical structure, and you solve it. I mean, just look at the building blocks of modern machine learning. It's algebra, probability, statistics, optimization. These ideas weren't created for computers. They're hundreds of years old. They were created to solve human problems. Computers didn't replace this way of thinking. They just accelerated it on a scale we can barely comprehend. The tools are new, but the thinking is ancient. So let's look at this classic little structure from algebra.
ax plus b equals c. It's simple, it's elegant, we know some of the pieces, and our job is to figure out the value of the unknown, x. It's a simple puzzle with a clear framework for finding the solution.
Now look at this. This is a core equation from a simple neural network. The structure is, well, it's almost identical, but instead of just solving for one unknown x, the goal here is to find the perfect values for w and b, the weights and bias, so that the model can make the most accurate predictions possible. It's the same ancient idea, just supercharged for a modern purpose.
So when we say a machine learns, this is really what it's doing. It's not magic, it's just testing countless values for those weights and biases, adjusting them over and over and over again, until the equation becomes a powerful model of reality. It's the exact same problem-solving process Diophantus used, just happening millions of times a second.
From those ancient scrolls all the way to today's supercomputers, the essential purpose has not changed one bit. It has always been about this art of transformation, taking a messy, real-world question and turning it into a clean, solvable structure.
And this leaves us with a really fascinating question to think about. Is modern data science truly something new? Or is it just the latest chapter in a story that began thousands of years ago? Maybe today's AI isn't a new invention at all, but the ultimate expression of an idea born from a simple math puzzle a very, very long time ago.